Hey students, in this video we're going to talk about graphing polar equations. Okay, so the first thing that we're going to talk about is single variable equations. So when we're talking about rectangular plane or the x and the y plane, single variable equations are horizontal and vertical lines. So for instance, the line y equals 2 is a horizontal line at the y value of 2, and x equals 2 is a vertical line at x equals 2. These are single variable equations. They're considered special cases, and this is for the x and the y coordinate. So with polar coordinates, we can talk about single variable functions in terms of r equals a, where a is some number. And if I define r as being equal to 3, then this is talking about a radius of 3. So the single variable r equals 3 is actually a circle with a radius of 3. And it kind of goes along the radius 3 line, creating that circle. If we're talking about a r equals 4, then this would be a circle with a radius of 4. If we were talking r equals 27, this would be a circle with a radius of 27. For theta equals a value, if I have theta is equal to pi over 4, then we're talking about the angle measurement of pi over 4, and that's actually going to be a diagonal line that follows the pi over 4 angle measurement. This would be true for anyone. So if I had an angle theta is equal to pi over 2, this would be a vertical line at pi over 2. So these are what single variable equations look like on the polar coordinate system. Okay, so now we're going to graph a independent and dependent variable polar function. The function that we're going to be graphing is r equals 4 sine of 3 theta, where theta is the inside variable or the independent variable and r is the output variable or the dependent variable. So the first thing that we're going to do is we're going to pick our theta values, and usually the way that I do this is I kind of go along my polar coordinate plane and I pick theta values starting at 0. I'll do pi over 12. I'll do pi over 6, and again, I'm just moving in a counterclockwise motion. Pi over 4, pi over 3, and I'll do a few of them. I'll plot these points, and then we'll do a few more. So I'm going to start with these 5 coordinates. And to find the r value, so these are the independent, I've picked these, just kind of again building counterclockwise starting at 0. And I'm going to pick I'm going to use that r is equal to 4 sine of 3 theta to find the r value. So the first one is 4 times sine of 3 times 0, because that's the independent variable or independent theta that I've chosen. And I can type this into my calculator, or I can use my unit circle and my order of operations to find that this r value is going to be 0. If you're typing these into your calculators, our angles are measured in radians, so please make sure your calculator is in radian mode. Okay, so then I have a point. My theta is 0 and my r value is 0. So I'm going to face towards the angle 0. I'm going to walk out 0 points, which is a point right there on the pole. Okay, so I'm going to keep going. I'm going to do 4 sine of 3 times pi over 12. And again, I'm going to use my calculator here to evaluate this value. And I will get a value of 2.8. And now for simplicity's sake, I'm only going to round to 1 decimal place. In other words, I'm going to point towards the angle of pi over 12, and I'm going to walk out to a radius of almost 3, but not quite. So pointing towards that angle, going out to there. Okay, so I'm going to fill out the remaining table, and then I'll go through plotting these points. Okay, so I've got my table filled out. I'm going to my next point is facing towards pi over 6, and I'm going to go out 4 units. And let me be in black. So 1, 2, 3, 4, out 4 units. I'm going to face pi over 4 and go out 2.8 units away. And then I'm actually at pi over 3. I'm going out 0 units. So I'm actually back at the pole here. So once I've made a full loop back at the place I've started, I'm actually going to go ahead and draw a complete this is what's called a petal on this graph. So I've done an enclosed shape, so I'm going to leave it there. Now what I'm going to do is I'm going to take a second and I'm going to create a table for my next couple of theta values. So I'm going to pick up at 5 pi over 12, and I'm going to do a few more theta values and then a few more plotted points. Okay, so I did a few more points until I realized I got back to 0, which would mean I would close in my shape. So the theta values that I picked, again going in counterclockwise order, was 5 pi over 12, has a radius of negative 2.8. So because it's a negative radius, even though I'm facing 5 pi over 12, I'm walking backwards. You can think of this as actually walking towards 17 pi over 12, and we're going to do that to almost 3 units. And then I'm facing pi over 2, but I'm walking backwards towards 3 pi over 2, 4 units. And then facing 7 pi over 12, but walking backwards towards 19 pi over 12, 2.8 units. And then actually when I am facing 2 pi over 3, I'm back at 0. So that closes in another petal. Okay, I'm going to actually keep this process going. I'm going to do one more full petal with you guys. I'm going to erase my current points that I have, and I'm going to do pick a few more points for me to plot. Okay, so I filled out the next couple points on my chart, and so now I'm going to keep plotting. So at 3 pi over 4, facing 3 pi over 4, I'm going to walk towards 3 pi over 4, 2.8 units. Walking towards 5 pi over 6, 4 units. Walking towards 11 pi over 12, 2.8 units. And then at pi, I'm back at 0. So because of that, I've made a full loop again, and I'm going to connect all those points. Okay, so from here, I am at 13 pi over 12. I'm actually going to switch colors here, so we'll do these in green. So at 13 pi over 12, I'm facing 13 pi over 12, but I'm walking backwards 0.8 or negative 2.8 units. So if I'm facing that, I'm actually walking towards the opposite angle, which is pi over 12. And if I were to plot that point, it would be right here on this same black point that I've already done. If I go to 7 pi over 6, I'm facing 7 pi over 6, but I'm walking backwards 4 units, and that would get me here. And actually what would happen is if I continue to plot points, all that would happen is that all of these points would start to repeat themselves, and this entire graph would just get repeated all over again. So this is the full complete graph, and we actually only had to go to pi to do that. Tomorrow we're going to talk about how you can create a full graph, what the domain needs to be, but for this one we just had to go to pi. Tomorrow in class we're going to be graphing with our calculators, and here are some calculator tips that are going to help us graph these polar functions. Please take a second, get this down, and then we will learn how to graph all of these in our calculator tomorrow.